Okay, so we're gonna start off with Mr. Farmer. Farmer.
Wait. Is this my punishment for logging in first?
Yep, that's right. You're the first one I saw, so you're gonna get you get to tell me how many sig figs are in this first number here.
Oh,
You even
3.
called them out on the email.
Oh yeah, I always call him out. You know, that's my job.
3.
3, that is correct. Okay, let's see. Oh, Aubrey, I saw you here. Aubrey, are you gonna help me out?
Yeah.
What about the second one?
2.
That is correct. Piece of cake, right?
Yeah.
Okay. Okay, so let's make it a little more challenging. You know, this is all pieces of cake. So we've talked about rounding and everything like that. So you have an idea of what we need to do when we round, right? So in this case, this is just showing you an example of that. So this is, we're going to have 3 significant figures. So we're going to be using this number as our rounding number. So if it's greater than 5, we're going to round up. If it's less than 5, then we're going to leave that number alone. Okay, pretty simple.
Yeah.
Okay, so 7, is it greater than 5 or less than 5?
Greater.
Okay, so then the answer is going to be 1.43. Piece of cake. So what happens if it's exactly 5 and there's nothing after it? So let's say it was 1.425, and there's nothing after this, and we're doing 3 significant figures.
You would still round it up because it's 5 or more, you round up?
Actually, no. You would actually, in this case, round it down.
Oh.
It would be 142. If there was a single digit after that, then we would round up. Okay? Because it was just that little digit there pushes it over that edge.
Wait, if you're rounding down, then why is it 1.42 still?
Well, you're not rounding down. You're leaving it alone, so you're not changing.
Staying the
that
same.
number. Yeah.
Oh,
Yeah.
okay. You said round down, so I was like, what?
Yeah. Sorry, it's habit. Okay. Piece of cake.
Yep.
All right, can I ask a question, please?
Sure.
So you said that if it was just a 5, and we're talking about the 7, right?
Yeah, we're saying the 7. If the 7 was a 5 instead of a 7.
Okay. All right. Never mind. Then my question's, I get it. Never mind.
I just drop it.
Okay.
Yeah.
Okay, so let's see those skills. Okay, I'm going to be a little lazy. I'll read the question, and then you guys need to help me out with this one. Okay, a student weighs a beaker and 4 different chemicals using different balances. The individual masses and their sums are beaker, 319.5 grams, chemical A, 20.460 grams, chemical B, 0.0639 grams, chemical C, 45.642 grams, chemical D, 4.173 grams, and the total added all together is 389.8389 grams. Ooh, a lot of words. Okay, so what do we need to do? Let's see. Nancy.
I don't know. What do we do?
You don't know what we do?
I don't even know what it's asking.
It's asking us to, we're basically going to be rounding it, right? We're going to try to find a number of significant figures.
Oh, okay. So when you're adding, you look at the one with the most significant figures?
Okay,
Or
so
no?
what is going to be the first thing that I should do when I'm adding?
Line them up?
Line them up. Okay, so let's go ahead and line them up. I'm gonna be super lazy.
Oh,
Okay, so I have them all here.
Mhm.
And then
And then,
we're gonna add them up.
yeah.
Okay, so let me find my. Okay. So I have it all added up. Now what do I do?
So the one with the no number, is it? So you know what? I don't know. I forgot.
Oh, are you tapping out on me? Who's gonna tag in for
hold
us?
on. Hold on. It says maybe you. So you line them up, then the one that doesn't have it.
So where am I gonna draw my line?
then where would we go off as far as like significant figures?
Karina, you wanna help her out?
After the 5?
After 5, yes.
Yeah.
Which would be the uncertainty.
So we're gonna be drawing it after the 5,
Okay.
okay? Okay, so we do it after the 5. So what is gonna be our answer?
So it'd be 8 or
390.
389.8.
So 389.8. Okay. Units?
Grams.
Okay. How many sig figs is that?
4.
4.
Piece of cake?
Yep.
Good, good. Okay, now you want something more challenging, right? Too easy. Okay, you guys already know about multiplication, so we don't have to go over it. Talked about division. We've talked about the metric system and the empirical system. Okay. So we're going to skip that, so you should know how to do those conversions already. Want to talk about temperature. Okay, so in the US, we often use what scale?
Fahrenheit.
Fahrenheit.
We use Fahrenheit. So the rest of the world, and often in science, not always in science, we use Celsius, right? So the conversion for Celsius to Fahrenheit is this equation right here that you see in front of you, right? So where T not Celsius or T degrees Celsius, that's the temperature in Celsius. The T not F, that's the temperature in Fahrenheit. So temperature in Fahrenheit minus 32 divided by 1.8 equals degrees Celsius. So can I remodel this equation so that I can get the answer for Fahrenheit if I'm given Celsius?
Yeah. You just
Okay, so
plug in
then
the
let's
numbers.
let's do that then, right? Okay, so we have T Fahrenheit is going to be equal to what?
Temperature measurement.
100.
T
I'm
Fahrenheit
just
is going to
kidding.
equal to 100.
Nope, I was
Wait,
wrong.
huh? No, 32.
We're changing our
We're
equation
changing
first
the
off.
equation.
Wait.
Okay, so if you do your algebra, you know, you shake off those cobwebs, you should get this question right here. I mean, not this question, this equation right here.
Oh.
Okay? Agree or disagree?
Agree.
Agree.
Okay? So let's test it out. So we know that water freezes at what degrees Celsius?
0.
0 degrees Celsius. Okay, so if we put 0 degrees Celsius here,
Mhm.
then what do we get for Fahrenheit?
32.
Okay, so is that true? Does water freeze at 32 degrees Fahrenheit?
Yes.
Okay, so water boils, let's use this equation here, at 212 degrees Fahrenheit. So what is that in Celsius?
Wait, what? What was the
Water
question?
boils at 212 degrees Fahrenheit.
100
That is
degrees
correct.
Celsius.
That is correct. Piece of cake?
So far.
Okay, good. Okay, so let's test your skills here. So let me give you a little more information. Okay, so we have Kelvin. Kelvin is the temperature scale that we often use in chemistry. The reason why we use the Kelvin scale is because Kelvin at 0 degrees Kelvin, that's considered to be absolute zero. It's considered to be absolute zero because at 0 degrees Kelvin, molecules stop doing this. They stop moving and they just are still. So they're frozen solid, so they can't move at all. So absolute zero is when the molecules stop moving or when atoms stop moving. So they'll stop moving completely. Okay, you guys got that?
Yep.
Okay, so the way you convert from Celsius to Kelvin, because 0 degrees Kelvin is actually equal to negative 273.15 degrees Celsius, the way that we convert is we take the temperature in Celsius and we add 273.15 actually. But if we get lazy, we'll use 273 just because, you know, occasionally we get lazy and we want that quick calculation, right? Piece of cake, simple?
Yep.
Okay, so let's figure this out. Okay, so here's three thermometers. So we have one in Fahrenheit, we have one in Celsius, and we have one in Kelvin. And you can see how they relate to each other. Okay, so you notice the change in temperature between Celsius and Kelvin are the same because it's being added. The only thing is the difference here is 100 degrees from freezing point to boiling point. The difference here is also 100 degrees between 273, which is our freezing point, to 373, which is our boiling point. Okay, now it isn't the same in this context. Okay, so the difference isn't the same. And that's going to be important later on when we start talking about heat and energy. Okay, and then the reason why we always have to convert to Celsius or Kelvin when we do those things. Okay. Okay, so here's the hard question. So let's see, we're gonna have Veronica. So you think I forget?
No, but I mean, I'm not confident in this at all.
That's all right. We're building up confidence.
Hold on, I'm writing this down. So we are gonna do from Kelvin to Fahrenheit. So it's gonna be 273.15.
Okay.
Is it gonna be minus or plus 288?
Okay, so let's think about the equation. What did our equation say?
I think it was
It
plus.
says TC plus 273 is going to equal our TK. Correct?
Yes.
Okay, so we're giving it in Kelvin.
So is it gonna be 288 plus 273?
Okay, so is it going to be 288 plus 273? So what are we solving for in this case?
288 minus 273.
That is correct. It'll be
Oh.
288
I have
minus.
everything.
Yeah. So we have TK minus 273. And that's going to equal our TC, right? Or temperature in Celsius. So that's going to equal 288 minus 273. So my math skills aren't all that there used to be cracked up to be. So if I remember correctly, that should be about 15.
Yes.
And that's what degrees what?
Celsius. Degrees Celsius.
Okay. Okay, so we have degrees Celsius, but we want Fahrenheit. What do we need to do now?
Plug it into our Fahrenheit equation.
Plug it into our Fahrenheit equation. We're given Celsius. So what is our Fahrenheit equation when we have Celsius? TF is going to be equal to what?
1.8 times the 15 degrees Celsius plus 32.
Okay. I'll just start off with the equation first and then.
Oh, sorry.
That's all right. You know, so one thing those teachers got to do to kind of make sure that all the students know where we're starting from. So then we just plug it in, right? Plug and chug. It's like a beer. I love plug and chug equations. That's a decimal. Okay, plus 32. What does that equal?
59 degrees Fahrenheit.
Okay, so we got 59 degrees Fahrenheit. Piece of cake? Yeah, no? Good. Okay. Excellent. Let's move on. Okay. Let's see. So now we're going to get everybody involved. We want to make everybody feel a little good about themselves today. So I want you guys to go ahead and 1, 2, 3, 4, 5, 6. 2, 4, 6, 8. Oops, sorry. 2, 4, 6, 8, 10, 12. Perfect, right? Okay, so we have 1, 2, 3, 4, 5, 6. We got 6 open spaces. So let's see. I'm going to put you guys in some groups. I want you to discuss it. And then you guys are going to come back, answer the questions, filling in the spots. Okay, so group 1 is going to be responsible for this first spot. And I think it tells you it tells you your group once I put you in your groups. Group 1, let me clear, hold on. Okay, so group 1, this is going to be group 2, this is group 3. This is group 4. This is group 5. and this is group 6. So do me a favor, take your phone out, take a picture of the table so that you guys can discuss it and argue and fight, and
Okay.
then come back here. Okay? I want drama. If there's no drama, nobody gets anything out of it. Okay? Ain't that right, Karina? Is your boo there today?
No.
No? Okay, you guys ready?
Yep.
Let's see. Let's see. Okay, do we have a group 1 representative? Group 1, right here. Group 2. I think group 2 we have to disband. Group 3. Group 4. Do you want me to help you out with your groups? Group 5.
Yeah, I don't know what purpose. Ooh.
What chapter is this in?
This is in chapter 3. We're getting ready to start chapter 5 here after we finish this. So group 1. See, group 1 we had Sanwana and your road dog. Did she leave? Are you there, Sanwana?
Yeah, for that one I got -13.
Negative 13?
Yeah.
Okay. Okay. Group 2? Oh, we don't have a group 2. I'll provide that one. So I'll put the group in circles. Okay, so it's group 3. Group 3, that was Judy, Marisol, and Tiffany.
Pick one.
We got 41.
41.
Yeah.
Group 4,
We got 314.
314. Group 5,
196.
196. Group 6,
90.85.
okay. So 90.85 would be all of the little digits going on there. Could we round up to 2 sig figs
No.
or 3 sig figs?
Wait, can we?
I don't know. So if we have 364, and then we have, was it 273?
73 or 74?
73.15, right?
Oh, okay. I think I did the math wrong then.
No, actually, your answer is right when you do the math. So if I did that, then I would end up with the 90.85. So where would I draw the line?
I'm guessing. What do you mean draw a line? I'm lost.
We're looking for to get the number of significant figures.
Okay.
Where would I draw the line to determine where I'm going to use to round or I'm adding these two together?
Wouldn't it be the?
Subtracting.
Wouldn't it be the one after the decimal?
The one after. So this number up here, where would I draw the line? The top number.
I have no clue. I don't know. I'm gonna tap it out.
You're tapping out.
I'm tapping out.
Maria, you're gonna help him out? Are you there, Maria?
After the 4. After the 4.
After the 4.
Yeah, it just came to me.
Okay. Okay, so we know that then, since it's after the 4, we're going to use the 8. So is 8 greater than 5?
Yes.
Okay, so then our answer would be
91.0 or 91.
91. Okay, so piece of cake.
Yeah, I struggle a little bit, but we'll get there. We'll get there.
So it's a work in progress, right? We're building. We're building a strong foundation so we can finish building our house. Okay, good? Are you guys good?
Yep.
Excellent. That's what I like to hear. Okay, so let's go. Keep moving. Okay, so density. So density is basically a proportionality, right? So density at a given temperature is going to be constant. So the density of water at 20 degrees is always going to be what? Does anybody know the density of water?
1.
1. That is correct. So the density of water is always going to be 1 gram per milliliter. At 20 degrees all the time. So if I have a metal, right, let's say I have aluminum. So the density of aluminum is always going to be a constant number, right? So it's a number that is always going to be exactly the same all the time at that particular temperature. Now, when you change phase, then it's going to change. Right? So if we have liquid aluminum, that's going to be a different density than solid aluminum, okay? So, but the key is that it's a proportionality, right? Meaning they're proportional to each other. And so density allows mass to be proportional to volume. So we basically can say mass is proportional. This here means proportional to volume. So since we have a constant density, we can say mass is equal to density times volume. Piece of cake? So then we can just finally say density is equal to mass over volume. Okay? So we know that the density is equal to mass over volume. You got it? Yes, no, maybe? Okay. So let's work with that. Oops, I carried away. Oops. And this is just basically telling you what I just told you. And so we'll see density is most commonly expressed in grams per milliliter or grams per cubic centimeter. So if oops. Beautiful. Okay, so these are the units. Occasionally you'll see it in grams or kilograms per liter, but that's on occasion, okay? And the last thing is that density is temperature dependent. So the density of ice is going to be different than the density of water. Would you guys agree with that?
Yes.
Okay. What is one way that we can determine that?
The ice in the water.
Put ice in water. So what happens when we put ice in water?
The ice floats.
The ice floats.
Yeah, and it starts dissolving.
Okay. So the ice floats. So that means that is it more dense or less dense than water?
More or less dense?
It's less dense. Okay. Piece of cake?
Yeah.
Okay, so what about water and water vapor? So like when you're boiling water, why do you get bubbles?
Temperature?
Okay, yeah, because of temperature, but more physically, why are we getting these bubbles?
Is it because the water is evaporating?
Is it because, okay, is it because the water is evaporating, or is it because it's changing?
Oh, it's
Is it
It's
changing its,
evaporation. What was that?
it's not a chem, is it changing its, how would you say it?
Physical change?
yes.
Yes,
There you
not
go.
chemical change, but physical change.
Yeah, so we're going through a physical change, right?
Dang, how was I thinking like that? That's crazy.
Okay, so then basically you're starting to go from water to a gas form, and so those gases are, rising up because it's less dense than the water, right? See, water wants to rise up. I mean, steam wants to rise up. Okay, so this is basically just showing you our ice as a solid. Here's water as a liquid. And when we put it together, on top, this is ice and water. On the bottom, this is solid ethanol. So it's ethanol that's been frozen and then in ethanol, right? So in this case, and often in most cases, your solid is heavier than your water, right? And so it's more dense than your water. But water is an exception. It's kind of unique in that sense. The weirdo. Okay, so these are some examples of substances and their densities. And so wood, does wood floats on water?
Yes.
Yes.
Okay, now you know why, it's less dense,
Yes.
right? Piece of cake?
Yep.
Okay, good.
I have a little question.
Okay. I may have a little answer.
It kind of has something to do with it because you said that. Okay, so you said wood floats because it's less dense, right?
That's correct.
So I'm guessing our bodies are more dense, and if you were to drown, you become less dense, and then you float. Is that what I'm getting at, or
Yeah,
no?
I understand. Are you trying to get rid of bodies?
No, I'm not. That's why I didn't want to ask the question. No.
Okay,
Plus,
so
we don't have a body of water around here.
technically you can start off floating, like you can float on top of water, right? But
Okay,
after a
that's
while,
true. Yeah.
you'll actually start sinking, right? So the first thing that you do when you start floating, you take that deep breath, like, right? And so you put all of the air in you, right? And
Right.
so as soon as that air starts leaving your body, then you start sinking and sinking and sinking and sinking.
Okay.
But when you die, what happens is that your body has a lot of bacteria and it starts breaking things down. When it starts breaking things down, it starts making all of these gases. So then the body will start rising. So that's why dead bodies start rising after a while if you don't sink them down. So tie them down really well when you decide to get rid of the bodies. Okay.
Where I'm not trying to get rid of my body.
Tie it to some rocks.
Whoa.
Okay.
Dang, Nancy.
I could just imagine if my boss hears my lectures. Ooh, they're
Yeah.
gonna have fits.
I'm sorry. I didn't mean to. I'm sorry.
No, it's okay. I'm just teasing. I've said worse, so I'm not worried too much about it. They're gonna fire me. They're gonna fire me. What can I say? Okay. So we have mass of 50.00 milliliter samples of methanol is 39.59 grams. Determine the density of methanol. See. I think I'm gonna have to pick on Jamie. You got this, Jamie? And I like that little table that you sent me. It's a nice little table.
Oh yeah. I need to take a picture of that.
She doesn't realize she's on mute.
Jamie.
Oh
You're
my
on
God,
mute.
I forgot that I was on mute. Okay. Alrighty. So we are looking for the density, right?
That's right.
So we're going to start with the mass.
Okay.
So it's going to be 50.00 millimeters. Do I
Okay.
use annotate? Do you want me to do it?
Yeah, that would be great.
Okay, cool.
Saves my finger a little bit.
All right. I'm not used to this, so if it comes out weird, just ask me.
It's a little 50.
Oh, it's what?
I said it's a little 50. It's a big 5, little O, 50.
Okay, yeah. Oh, hold
It's
on.
okay. I'm just
Did I
teasing.
fix it? Oh, okay.
No, don't worry about it. I'm just giving you a hard time since you were making a comment on it. So
So let's do this. I forgot to start off with this, so I'm sorry.
that's right.
And then methanol here is our volume, so it's 39. That's a 3. That's a 9, and then.
Wait, isn't it flipped?
What do you mean? Did I flip it?
So
No, because the grams is on top, isn't it?
that is correct. So milliliters is volume, right?
Yeah, so that goes on bottom.
So that should go on bottom. That's right.
Oh, snap. Okay. Hold on, let me undo everything. Thank you. Let's start over again. So it's going to be what happened to the line? Oh, that's supposed to be a line just by itself. I don't know. It's because every time I write, like writing it in or whatever, it just like disappears. Do you guys notice that too?
Until it takes a moment for it to show up.
Oh, is that what it is?
Delay. Yep.
Okay, and then so we divide that. So it's going to be, so our dense equals to D 0.79, right? Am I wrong or am I right?
How many sig figs?
It should be 2.
2?
No, it should be, where we're going by the grams, right? So it's 4, right?
Okay.
There
So
you
actually, you would go by grams and by volume. How many are there for volume?
So for volume, there's 4.
There's 4. And then for grams?
Oh, there's 4 too. So I'm missing. Okay. Okay. So my answer was 0.7918. So do I round that up? So it'd be 0.792.
No. Would that be 4 significant figures?
Oh yeah. Okay. Hold on.
Lipids.
Right? Is that it?
Yep.
Okay.
Okay. Who's saying flip it? Flip it.
No, I'm Googling lipids. My bad.
Oh, okay.
Yeah.
My bad.
I have a question.
Yes.
The original formula says density equals mass over volume. So I just wanted to know why we were flipping and putting mass on bottom and the grams on top.
No, we have mass on top and milliliters on bottom. Right?
But doesn't the question say mass of 50.00 milliliters?
Read how it's written weird. Okay, it says the mass of a 50 milliliter sample of methanol is 33.59 grams. So it's saying the mass is
Oh,
this.
okay. I was looking at it wrong. Okay.
Yep. And that's the same thing that got you to, Jamie, is how it was written. You kind of have to be careful with how things are written and how they're, so be careful with how you read it. So that's why you initially thought the same thing. And so it always helps to put the units, because if you don't put the units, what happened, Israel?
If you
Take
don't,
yourself off of mute. What was that?
if you don't put the units, you confuse yourself.
You confuse yourself, and then what happens on the test?
You get it
don't get a
wrong.
point.
You get points taken off. That's right.
So if I would have, like, theoretically speaking, if I would have done it the other way, I would have gone points taken off for it, even though I had the correct answer.
Well, you didn't have the correct answer because you did it the other way, right?
Yeah.
Is that
it wouldn't
true?
It wouldn't give you the same answer.
It's not gonna. Yeah, it's not gonna give you the same answer.
Oh, so that one I just got it wrong. Okay.
Yep.
I had
then-
one more question.
Yep.
So you know how you asked her at the end how many sig figs were there? For every question that we have, are we always gonna, I guess, ask or look for how many sig figs we're gonna look for so that the answer pertains to the sig figs?
Yes. The majority of the questions that you have, you should be paying attention to sig figs. Occasionally, the
Okay.
multiple guess questions, depending on which chapter they came from, they may not use sig figs because it hadn't been introduced yet. Like in chapter 2, we
Okay.
hadn't talked about sig figs. So you want to just go with that answer that's closest to the correct answer. But if they ask you, be sure to include sig figs, be sure to include sig figs.
Okay.
Okay?
hmm Okay, so it would be marked wrong if she would have just put 0.79.
That's
And
correct.
not
She
the
would get
1/8.
points. She would get points knocked off. So by her showing her work, I could go through and figure it out, right? But if she hadn't put units, it makes it a little bit harder for me to figure out. The more harder you make it
Okay.
for me to follow you, right? Like if she had put the equation, if she said density equals mass over liter, I'd have given her some points just for having that equation, even though she
Okay.
may have switched it the first time. But if she didn't do that, then I can't give her points for it because to me it looks like she just didn't understand the problem, right? And not
Okay, I
that
see what
she
you're saying.
mistaked it.
Mhm.
So yeah, the easier you make it for me to follow, keeping your units in check, showing me an equation, that always helps. Like showing me an equation shows me that you're at least in the right ballpark or you're way out of left field, right? So by putting that equation there, she just said density equals m over v. That would have given her some points already. And then when she put
Okay.
the numbers in and screwed it up, she at least got a couple of points, even though she had screwed it up, you know?
Okay.
Okay. So don't take it personal, Jamie.
I am. No, I'm just kidding. Well, at least I'm getting practice and I know, like, what I'm doing wrong. So
Yeah.
I'll be prepared. Thank
Yeah,
you.
and then also, again, we learn more from you by making that mistake. And so,
Yeah.
like, Eileen immediately pointed out, okay, so would she get points for this? Would we get points for this? So she's kind of even narrowing it down even more, right?
Yeah. And you know what? Like, I think my issue also too with like even like with the other with like certain questions, like even with homework, I'm not like I'm reading it, but I'm not like really actually like really reading it thoroughly because I feel like I had the formula, but I kind of mix it up.
Yeah.
And that's where I go wrong.
Yep. And so
Me
sometimes
too.
you just need a USA. Okay, let me reread this one more time to make sure I understand it, you know?
Yeah.
Okay, let's move on. Okay, so here's a question. The density of a certain machine oil is 0.190 grams per milliliter. Find the volume occupied by 196 grams of that oil. Let's see, who's going to be, anybody want to volunteer?
Me.
Hey, Nancy.
Okay, so you start off with, do I have to say the equation and all that?
Well, put it on there
Okay,
and talk as you go.
okay.
Come on, you're the instructor in the class now.
Okay. Okay. So, density. I don't like to switch the formula around. I just plug them in that way. I don't know if that makes sense. So, oops. So then I would put 0. Man, this is hard. 0. Should I put it? the volume. So we're solving for the volume.
What are the units for 196?
Where did I get that from?
I said, what are the units?
Oh, I was like, what do you mean? Yeah. That's a G.
Okay.
Okay, so now to get, let me write it down. So now you would, I think I would divide the grams by this portion, the density.
Okay.
So it would be 196 and then the answer I don't know if, does anyone have a calculator?
I do.
My phone's updating and it's not letting me
Okay.
open.
The answer is 215.3846154.
Okay, I got stuck after the 3. What?
8,
8.
4, 6, 1, 5, 4.
6, 1, and so there's 3 significant figures.
Okay.
So you would round to 215.
Okay. What are the units?
Oh, is it? Hold on, ML?
That's right. Okay, piece of cake.
I have one more question.
Okay, Eileen.
Yeah. Okay. So I get the answer and everything that she got, but at the beginning, I had originally thought we were gonna go with the volume equals mass over density, because it's saying find the volume.
And that's what she did, but she just did it a little differently. She didn't do the convert. She didn't change it up here. She didn't change it initially. Oh, you guys can't see what I'm doing. Oh, yes, you can.
Yeah, you can.
Okay, so she didn't change it here. She just went through the process and she changed it at the very end.
Oh, okay.
Yeah, I like to keep the equations the same because then I get like more, I guess, kind of mixed up.
So here is what she's at the end. Volume is equal to
Okay,
that.
I see it. She's just breaking it down because that's
Yeah.
how she did. Okay.
She's a number person. You can kind of tell by how she talks. And so, you know, she's good at moving the numbers and not necessarily the letters and stuff. So,
Okay. I was just wondering.
Yeah, this would be the equation. Okay, piece of cake.
Yeah.
I got a
Good.
different answer in my calculator.
You got a different answer?
Yeah, dividing 0.9109 into 196, right?
So you're dividing 196 by 0.910.
Yes.
Okay, plug it in. What did you get?
I got 215.171.
215.171. 196 divided by 1. That's what I got. I'll plug it in again, see if I'm wrong. So I got 215.3846154. That's what I got.
What's wrong with my calculator?
So did you, what you said, you put in 196 divided by what?
0.9109.
Zero.
Well, this is a G. That's not
Oh!
9. Sorry.
No, my bad.
You're just insulting her writing and everything.
No.
Rude.
Okay, I'm retarded. I'm sorry.
No, it's an easy mistake. That's the best part about writing on this board. You're going to mess up a little bit, and mainly because of things look like weird numbers. Okay, are we good? Everybody else? Okay, so you guys know Dalton, right?
Yeah.
Okay, so Dalton, he gets around. You know, he does a little bit of biology. You know, he's one of these rich guys that have a trust fund and stuff like that. So he had plenty of time. And during this time period, a lot of the scientists, they were money. They come from money. They had money. And they didn't do anything except think about science because that's what they considered to be fun, right? Where, you know, people like us, we had to work, you know, work in the fields, work here, just to work to make ends meet. And there's a point where society kind of changed and they were like, well, you know, those people, they may have something to offer, you know, maybe not much, but we're going to give them throw them a bone, right? So now we just work differently, right? So a little bit. So Dalton had all this time, so he started thinking about atoms. And so he made up these theories about atoms, and he looked at chemicals and had these ideas going on with some of the stuff that had been published during that time period. And so what he did was, first thing that he says, each element is made up of individual particles called atoms. Then he said, atoms are indivisible. Then he said, all atoms of one element are identical in every respect. Atoms of one element are different from atoms of another element. And then lastly, he said, atoms of one element combined with atoms of another element can form chemical compounds. Okay, so this is basically giving you the illustration of Dalton's theory, right? So again, atoms of an element, elements are made up of atoms, and all elements of a given atom, all atoms of a given element are identical. Okay, now I want you to sit here and think about this as we talk about this lecture. And then I want you to tell me later on whether you believe Dalton's law held up through everything that after you listen to everything that we discussed, okay? And then which parts of it didn't hold up, okay? So he also said that atoms are indivisible. Basically, he was saying atoms cannot be destroyed or created. Where did we hear this at as well?
Matter.
What was that?
Matter.
Matter? What about matter? What law?
Can't be free.
What was that?
Law of conversion.
Law of conversion? Law of conservation, you mean?
Yeah.
Law of conservation. Okay. You started, you got a C and a V in it. We were getting there, right? Okay. So all the atoms of a given element have the same properties, including mass. Atoms of different elements have different masses. Okay, so you know it kind of makes sense. You know, you would assume that carbon and oxygen aren't going to have the same mass, right? Because they're two different atoms. But all carbons, they should be about the same mass, right?
Mm-hmm.
Okay, so let's see. Atoms of a different element may be combined in atoms of a different element may combine in a ratio of small whole numbers to form compounds. Okay? Okay, so law of multiple proportions. So that basically is that last part, right? So that kind of brings us to this. So we have carbon monoxide. So what is the ratio of carbon to oxygen in carbon monoxide? Mon means like mono, which one?
One.
Okay, so it's a 1-to-1 ratio, right? So carbon dioxide, what is the ratio of carbon to oxygen?
1:2.
1:2. Carbon monoxide and carbon dioxide are two total different compounds. They behave differently. For instance, when we breathe in oxygen, what do we breathe out?
Carbon dioxide.
We breathe out carbon dioxide, right? Carbon monoxide, if we breathe it in, it kills us. And even in the presence of oxygen. So even if we have oxygen present, carbon monoxide would kill us, right? Carbon monoxide poisoning. So you guys heard of that? When people sit in cars and...
Oh, yeah, I heard of it. I was actually gonna ask you if that was an example of it.
Yep.
Okay.
Yeah. Well, carbon dioxide can kill you too if there's no oxygen at all in the room, right? So if you have no oxygen at all, carbon dioxide can kill you. But carbon monoxide can kill you even if there is oxygen in the room. So they're different and they behave differently. Okay? So, and that's what basically they're saying. You could have two different compounds that have the same elements in them, right? But they could be of different proportions to each other. And that's the take-home message. Piece of cake? Simple?
Yes.
Okay, good. So let's talk about the electron. So Dalton had said things were indivisible, but we have subatomic particles, right? Subatomic particles. So one of those subatomic particles is the electron. Electron has a negative charge associated with it. It also has a mass that is really, really small compared to the mass of a hydrogen nucleus, and which is primarily a proton. So a proton weighs pretty heavy. It's 1,837 times heavier than an electron. So that's kind of like, let's put this in perspective. If I put a speck of dust on my shoulder, I weigh 210 pounds, and I get on the scale, is that going to affect my weight?
No,
No. Why?
because it's like too small of a number.
It's so tiny compared to the rest of me that it's not going to make a difference, right?
Yeah.
So that's exactly what an electron is. Electron is so tiny compared to the proton that it's not going to make a difference in the weight. Okay, so that's going to be really important here. So keep that in mind. Okay, so I told you that it has a negative charge, so it has a -1 value. The symbol that we use is E-. And its discovery was credited to J.J. Thomson. Okay. So initially, the way that they kind of describe the model of an atom is that you had this positive charge sphere center that's kind of jelly-like and stuff like that, and then you had these things that were sticking on the outside of it, and that would be your electron. Have you guys ever had? There's what is it? There is an Indian food pastry, and literally it has like a syrup and everything around it, and then there's all of these sugar molecules on the outside.
Is it fry bread?
What is it called?
Indian fry bread?
Yes. Okay. So that there is an example of what they kind of thought it looked like, right? So those sugar molecules are kind of like the on the outside of it. It's kind of like a sugar donut and stuff, a donut hole with sugar on it. So that is like your electrons, and then the positive charge or your nucleus and all that stuff was thought to be all of the dough and stuff of it, right? So that's what they thought what it was initially. So they call this the Plum pudding model, and it's actually named after a guy named Pudding, right? And they just kind of, I guess, mess with them a little bit. Plum pudding, So Rutherford basically set up an experiment, and he was like, you know what? I don't think that plum pudding model is a bunch of BS, right? So what he did, he took alpha particles. Alpha particles have a positive charge associated with them. He shot these alpha particles on this gold foil. So what he saw was that in some cases, these alpha particles would just shoot by and just go straight through. But if they hit the center of the atom, or what the nucleus is, right, it would bounce off. So if you have a positive bouncing off the center of something, what would you assume about that center of something? A positive molecule bouncing off of it.
Oh, that it's positive as well?
It's positive as well, because if we have positive and positive come together, what happens?
They like
They
separate,
what?
like not separate, but they go the opposite direction.
Okay, so they repel, right?
Yeah.
Okay, so they repel. And so that's exactly what they saw. And so based upon this, they were like, you know, there must be something in that middle, in the nucleus of that atom, that is causing it to repel. Hence, the name nucleus get coined for the center of the atom. So the center of the atom is the nucleus, right? And the nucleus is made up of two components. And I'm going to show you this in a second. Come on. So here's the nucleus of the atom. Here we have what we call the electron cloud. So remember, the electrons are so tiny, so they're actually rotating around the nucleus of the atom. The nucleus of the atom has a positive charge, the electrons have a negative charge, and they kind of hold together. They hold each other together. So the nucleus positive, the electron's negative. And so they have this attraction going on to kind of keep it nicely going. But the electrons are constantly moving around it and stuff like that. So it forms what we call the electron cloud. So in the nucleus, we have two components. We have the protons, which is a positive charge.
Neutron.
And we have neutrons, which has no charge. This is positive. This has no charge. So we'll put a 0 by it. It's neutral. And then the electrons out here are going to be negative, right? Okay. So the nucleus is a positive charge overall. The electrons are negative, and your neutrons are neutral. Okay. You guys got it?
Yes.
Okay. So we're going to jump ship, and there's all of these other slides that I'm supposed to show you, but I want to show you something else first. Okay. So let's go to P table. You guys have your periodic table available?
Yes.
Yeah.
Excellent. Okay, so I'm going to give you some definitions so that you guys keep this in mind. And you're going to need it. It's going to be important. It's going to continue to be important for a lot of different reasons. Okay, so first off, here. First off, let's start with, this is hydrogen, right? So this number up at the top of hydrogen is called your atomic number. So your atomic number, and I'm telling you this now so you guys will know, your atomic number tells us how many protons that atom has. So it equals the number of protons. So what is the number of protons for hydrogen?
1.
What is the atomic number for palladium?
31.
31. So that means palladium has how many protons?
31.
31.
Okay, piece of cake?
Yes.
Okay, now every element on this periodic table has a neutral charge. Okay, so now we know protons has what type of charge associated with it?
Positive.
Positive charge. Okay, so then how many protons does hydrogen have?
1.
Then how many electrons? Because we know electrons are negative charge. How many electrons must hydrogen have?
1.
1.
I don't know.
Is it 1? There's like a little number at the top right corner of the element.
Yeah, but that's the atomic number, right? Which means the number of protons.
It's on the left. She said on the right.
Yeah, on the right top corner, there's a little 1 on the top.
On the right top corner. Where are you talking?
On my table,
Mine.
on my
your
table, I printed the same one that you have on the screen. And on our little box, on the hydrogen box, at the top left, there's a big number 1, and then there's a number 1 that's small.
Okay, stop cheating. Hey,
Wait,
I'm not
what?
cheating.
Mine looks just like the ones on the screen, and it's the same one.
Yeah, it's the one that I printed from the screen, and on my sheet, it has little numbers at the right, on the right top corner. So I'm assuming that that would be the answer, right?
sorta. It can be a little distracting because when you get down to, let's say you get down to beryllium, how many does it have in the
It
right?
has the number 2 on top of another 2.
Uh-huh. Altogether, that's what?
4.
Okay. So you have to add them together. But that's, yes. So that would actually tell you the number of electrons altogether.
I don't see the other number.
It's if you go to the print, if you actually print the
I have the other one at home.
you actually print the PDF.
Uh-huh.
Okay.
So you
So
see
the
here.
number, uh-huh.
Oh, okay. I see it on
It's on your, yeah, it's on the screen at the top right. It's really small, but it's there.
You see it right there? Yes. Yes, that'll be your number of electrons, right? But again, stop cheating. You don't need to do that.
I have a question. So is that always the same for all of the elements on this table? The top right is always the electrons, or?
Yes. But you want to add them all together. If you add them all together, they should equal the same number as your protons, right?
Okay.
Okay.
So it's always going to be the same number as the proton?
Yep. Well, not always. When it's an element, yes, it is.
Yeah.
But when it's an ion, it isn't. We'll get to that. We're working it. You guys are throwing off my roof here. Slow down. Relax. Eileen, look at you, causing problems already.
Sorry, I was just wondering because I'm like, well, the top left has a proton, so I'm assuming the top right number has to mean something.
Okay, so here we have, and they actually show it up there, right? So we know that because it has to be neutral, all elements on the periodic table have to be neutral, right? So the number of protons have to equal the number of electrons, okay? Now you guys know this, right?
We do now.
Okay, good. So tell me, gold. What is the symbol for gold?
It's a
AU.
AU
With
stole
big
my
A,
gold,
little.
right? AU stole my gold. So how many protons does it have?
79.
79.
How many electrons does it have?
79.
Okay, piece of cake, right? Simple. Good?
Yeah.
Okay, you want to make it harder? Let's make it harder, right? It's too easy.
No.
It's too easy. Gotta make it harder now. Okay, so we have atomic mass. It's also called atomic weight, so I'm going to put weight in parentheses. Although we know that that only applies when we're on Earth. Let me spell weight. Okay. Okay, so the atomic mass is given to us right here. Now, I'm going to kind of explain this, and then I'll try to explain it a little bit later. So just kind of bear with me a little bit. So this here's our atomic mass. So our atomic mass is basically the sum of the protons and the neutrons. So it's our protons plus the neutrons. Okay? Basically. More exactly, I'm going to tell you the mass number. The mass number is basically equal to our atomic number, but it's a whole number, right? Or I'm sorry, not atomic number, atomic mass. So do you guys know what I mean by a whole number?
Yeah, no decimal point.
No decimal points. Okay, so it has no decimal point associated with it. So that means we have to round up or we have to leave it alone, right? So 1-digit number. Okay, so what would be my mass number for hydrogen?
It would be 1.
It would be 1.
1.00. Oh. Oh,
No,
the
what
mass.
would be the
Okay.
mass number?
Okay.
Because we're trying, because.
That's right.
Okay.
So I should probably do this. Okay, so our mass number is actually really equal to protons plus neutrons, because we can't have a half of a proton or half of a neutron, right? So if I cut, what am I going to cut in half? If I cut Marisol into quarters, right? Is she alive?
She could be.
To cut off her head, well, I guess it depends on how I cut her, right? So if I cut her this way, right? Cut off her head first. Is she going to be alive?
No.
No. Okay, so that's the same thing with our protons. We can't cut it in bits and pieces, right? We're talking about the whole thing. They're one solid thing, okay? So we have to look at it in terms of the mass number. So it's really the mass number is going to be equal the protons plus the neutrons, okay? You guys got that? Okay.
Wait. Hold on. So when do we use the decimal point? When you're asking for what?
We'll get there. Just chill for a minute. Let me build you up to it. I'm building you up to it.
Okay, okay.
You guys are so excited. That's good. I like it. Okay, so in this case, okay, so carbon, what is the atomic mass for carbon?
12.
12, okay? So what is the mass number for carbon?
Ooh. The mass number for carbon?
Yeah, so is the atomic mass of carbon 12?
Yes.
Are you sure?
Wait, what?
Is the atomic mass for carbon 12?
Yes, it is.
Are you sure?
Yes, because it says that it would have to be a whole number, right?
No, the mass number has to be a whole number.
Oh, okay. Oh, no, so the atomic mass number would have to be the 12, what is it, the 12.001, is it?
That is correct. So let's go like this.
Okay.
So we have atomic number. Okay, so we're going to start with carbon. Symbol for carbon is what?
C.
Okay, so our atomic number for carbon is?
Atomic number for carbon is 6.
6.
Our mass number for carbon?
Is 12.
Oops, sorry. Our atomic mass for carbon?
12.011.
Number of protons?
6.
Number of neutrons?
6.
Number of electrons?
6.
Okay. Piece of cake?
So the number of neutrons is also always the same?
Nope.
Wait.
Let's do a different one. Let's do gold, since we were talking about gold earlier. Okay, gold. What is the symbol for gold?
AU.
Hey, you stole my gold. Okay, how many, well, what is the number, what is the atomic number?
79.
9.
What is the mass number?
196.97.
Okay, So you said it's what?
196.97.
But
So
we would round up.
196.
So 197.
197, that's correct.
Oh, you're right.
So I just skipped the atomic mass. So the atomic mass is going to be what?
It would be 196.97.
Isn't it the whole number? 196?
No, the atomic mass is going to be the one with the decimal.
Okay.
The mass number is going to be the whole number. Okay, number of protons.
Oh, just kidding.
79?
79. Number of neutrons.
118.
Number of electrons.
79.
Piece of cake?
Yes.
Okay, so it's just adding and subtracting, right?
Yeah.
Yeah, so she got the neutrons 118 because she just added the numbers at the top right.
That's one way of doing it, but you could have also done it instead of doing it that way, Eileen, because some of your periodic tables don't give you all of that extra money, right?
Mhm.
So what you can do is subtract your mass number by the number of protons. Do that for me,
Okay.
Eileen. And that's the traditional way of doing it.
Okay, so mass number minus protons,
Yep,
it gives you the neutron.
that's correct.
Oh, okay.
Makes sense right here, because since mass number equals protons plus neutrons. So if I subtract mass number by the number of protons, that's going to equal neutrons, right? Piece of cake?
Yes.
Excellent. Okay, so now let's talk about, now, who is harping at me? Well, what is that 1.008 for? What is that for? Why do I need that? Okay, you ready?
Rude.
Okay, so that is because they're naturally occurring isotope. An isotope is an atom that has the same number of protons, but has different number of neutrons. Like for instance, the three most common isotopes of hydrogen is, and I'm gonna write it, the symbol, and in front of it, superscript, meaning it's up high. So the most common one is 1. That's the one that we kind of see on the table. So that means that the mass, the new mass is 1, okay? Or the mass of that particular atom is 1. Then we have 2, and then we have 3. So these are the three most common isotopes of hydrogen. Now, all of them exist in nature. In real life, they all exist, but the one exists more because if you look at the mass number, I mean the atomic mass, it's 1.008. Okay, so that means that it's more abundantly, it's going to be this isotope compared to the other ones. Okay, so the difference between this isotope and the others, and we can actually isolate them, right? Based upon weight, we can use weight as a means of isolation. Okay, is this one has what? What do you think is going to be varying in this case? So in this one, how many electrons do we have?
1.
How many protons do we have?
1.
How many neutrons do we have?
We don't have any.
That's right, we have none, 0. Okay, so what about this guy? How many electrons do we have?
2.
So I heard somebody say 1 and I heard somebody say 2.
2.
Nope, 2 is incorrect. Right? Because it is hydrogen, hydrogen is always going to have how many protons?
1.
It's always going to have 1 proton. So then how many electrons must it have to balance it out?
1.
1.
1. So what do you think is going to be changing here?
The neutron?
The neutron. So how many neutrons do we have here?
It would be for the last one.
No, for the second one.
It would be 1.
It would be 1, right? Because 1 plus 1 equals 2, and that's our new mass number, 2. Do you guys get that? So this represents your mass number up here, or it'll be your atomic mass, okay? How much would we expect the 2 isotope to weigh? What would be its mass, atomic mass?
For which one?
This one, the middle one.
It would be 1, right?
Nope. Because you just told me it has 2 electrons, so why would it be 1?
2?
It would be 2. It would be exactly 2, right? Do you guys get that?
Wait, so why
your
was 2?
So this is your new mass number. This is also your new atomic number. I mean your atomic mass, not your atomic number. Your new atomic mass. Yeah, I hear silence. I hear crickets.
Yeah, because I got lost a little bit too.
Okay, so let's break it down. Let me get a little more room here. Let me move some stuff around so we can work our magic. Okay, so we have 3 isotopes, right? The difference between the 3 isotopes is the number of neutrons, right? Neutrons affects what? Does it affect the atomic number? What does the atomic number tell us?
The atomic
The mass, is it the mass number minus the proton? What was it?
The atomic number tells us what? Look on the
Number of protons.
the number of protons is written right here, right? So the atomic number tells us the number of protons, right? That's the only thing that the atomic number tells us. How many protons they are, and it also defines that element. So all hydrogens will always have how many protons?
1.
All titanium will always have how many protons?
22.
22. So we can have hydrogens that weigh differently, right? So are they changing their number of protons, or are they changing their number of electrons, or are they changing their number of neutrons?
Neutrons?
Neutrons.
Neutrons, because we know that the mass is dependent on protons plus neutrons. Protons are always going to be the same for that element. So the only thing that's going to be changing is what?
Neutrons.
Neutrons. Okay, so this here, by putting this number in front of here, superscript, that means we're changing the atomic mass of the atom, right? So it's still hydrogen, but now it weighs, in this case, it weighs 1, which it normally weighs. In this case, it weighs 2, and in this case, it weighs 3. So how many protons does this hydrogen 1 have?
1.
1.
What about hydrogen 2? How many protons does it have?
1.
1.
And what about hydrogen 3? How many protons does it have?
1.
Okay, so how many neutrons does hydrogen 1 have?
None.
0.
Okay, I hear somebody say 2. So help me out here. So if the atomic mass, none, okay, that's right, none. Okay, so it has 0 neutrons. So how many neutrons does hydrogen 2 have?
1.
Okay, so it's 1. And how many neutrons does hydrogen 3 have?
2.
2.
Okay, so you guys get it?
Yes.
Okay, so the new mass is given to us by writing that number there, right? So that lets us know that we're changing the number of neutrons that it has. Now let's talk about electrons. How many electrons does hydrogen 1 have? 1. How many electrons does hydrogen 2 have?
1.
1, right? Because a proton is positive, and I told you that all elements or all elements have to be neutral. So it always has to have the same number of electrons that you have of protons, okay? Unless it's an ion, which we're going to get to next. Okay, so let's see. In this case, for hydrogen 3, how many protons does it have?
One.
How many electrons does it have? It has 1. And then how many neutrons does it have?
One.
One.
Neutrons?
Or 2. 3 has 2.
Oh, I was
This
on
one, 3 has 2. There you go.
And this is what this is basically, is this the isotope kind of thing?
These are called isotopes, yes. So the definition of an isotope, is it's an atom who has the same number of protons but has a different number of neutrons. So that means that it has a different mass. Okay, so its atomic mass is different. Same number of protons with a different atomic mass, or you could say a same number of protons, different number of neutrons.
Can you say again which were the common isotopes?
So all three of these are common. You find all three of these in nature. But they exist in nature. The difference is that this will be like at 99.9%, right? And then this guy, so if we had 100, right? 100 of them are going to be pretty much that. If we had 1,000, this guy is about 0.01. And then this guy here is like, 0.02 or something like that, 0.02. And then this guy is like 0.08 or something like that, or they might be reversed. There's a table that actually tells you how much there are. So percentage of it, 99.9% of it is this. If we had enough of them, we'll see this guy and we'll see this guy, but it'll be at very low abundance compared to what you see this. So most of the time you're going to be picking up this, you're going to have a little bit of this and a little bit of that. So if you see a number that's closer to this guy, right? So this one is 23. This one favors the sodium 23 ion, right? So you have more 23 than you have of the 22. Okay, you guys see that? You understand that?
So is this where that guy was wrong?
Yes, this is where that guy was wrong. Because what did he say? He said all of them are exactly the same, right? But they're not. They have different mass. They can have different mass. Okay?
Can you give another example of an isotope?
Sure.
Moment, please.
I can.
Thank you.
Don't worry, you're going to have ample opportunity. Okay, so we have S35. So let's use this little table here. So we'll say, so if we have so you'll see it written like this, and you also see it written like this, S35. It's always pronounced S35. So that means it's an isotope. So we'll do S35 and then we'll compare it to just S. Okay? So let's start with S. What is the atomic number for S?
16.
16, sweet 16. What is the atomic mass for S?
32.066.
32.06. Okay, what is the what is the mass number?
32.
What is the number of protons?
16.
What is the number of neutrons?
16.
What is the number of electrons?
16.
Okay, it's great. I'm glad I have one person in the class. Did everybody else jump ship?
No.
Okay.
No,
You're
So-
here.
You still there? Okay, so you guys ready? Okay, so let's get it. So the atomic number for S35.
16.
16.
That's right. Atomic mass for S35.
55.
Repeat that, please.
Atomic mass.
Atomic mass would still be the same.
No,
32.
it would not be the
It's
same.
30,
Oh, it's 35 then.
It
35.
is 35. The mass number,
35.
35. The number of protons,
16.
number of neutrons,
19.
Yeah, 19.
number of electrons,
16.
you got it?
Wait, where did we get the 19 from again?
Because we have a new mass number, right? It's no longer 32, it now weighs 35. So we subtract the mass number by the number of protons. So 35 minus 16,
Next.
okay? Piece of cake?
Yeah.
Okay, you gonna try one more?
Yeah. Let's do one more, please.
Hey, give me a hug. Come here, little monster.
I have a question. Is this, I think it's the discussion question number 3 or 4.
That is correct.
The one that you said for us to finish and we'll get extra credit points.
Yep, the team that does the best, yes.
Okay.
Okay, so we're doing uranium.
Okay.
So
Are we gonna start with just the regular uranium?
let's start with the regular uranium, yes.
So for atomic number, that will be, where's uranium? 92.
Okay,
Atomic mass is going to be 283.
38.
38, yeah. That's what I got.
I'm sorry, 238.
238,
238, yes.
that's it?
238.03.
Okay,
And then for the mass, that's just going to be 238 by itself, right?
that's right.
Okay. See, I'm getting atomic mass confused with the mass number.
Yeah, I mean, they come from each other, but the mass number is a whole number, right? Mass number, whole number, okay? Where the atomic mass doesn't have to be a whole number. It can be a whole number, right? In the case of the isotope, it is a whole number. But in the case of this basically is the average, right? It's the average Joe. So it's a combination of everything, okay? So protons.
Would we get it wrong if we
protons.
just put the 238 instead of the decimal?
Yes, you would.
Okay.
Okay, number of protons.
92.
Number of neutrons.
146.
Is it
I heard like 4 different answers there. What did you guys get?
46.
You said 146?
Yeah.
you give the whole number there or like the whole? With
You
the,
tell me.
Yeah.
oh,
Are you going to have 0.03 of a neutron?
Um,
Okay.
and then it's going to be 92 electrons.
Yeah,
Okay.
oh, is it? I got 86.
Or did I get
Didn't
You said you got 86.
I? Yeah.
So we have 2.
Do you want to know where I got the 86 from, though?
Yeah.
From the chart that you filled out. That's what you put in for under there.
For uranium?
Yeah. Look
What
in.
chart did I fill out?
You put in the chart for our discussion, and you filled in a couple of them, right?
Uh-huh.
And that was one of them that you put in there.
Okay, but then that probably means that I'm setting you up for
Okay.
another type of
Because
question.
you were seriously like throwing me off big time.
Yeah.
I know.
Yeah. Okay, so that question is also taken into consideration. If you read the end of it, it says what at the end?
Okay.
You have choices between a what?
The
Element, ion, or
element,
isotope.
ion, yeah.
Just say it again.
Isotope.
You have the choice between an isotope, an element, or an ion. Have we talked about ions yet?
No.
Okay. That probably gives you a hint there.
Okay. So I'm right on the electrons then?
So you're right on the electrons, yes.
Cool.
Because they have to add up for the number of protons. Okay, so now let's talk about the isotope
And,
uranium 246.
all right.
What is the atomic number?
Would it be, would it be,
92.
would it still be 92?
246?
It's 92.
92?
It will be 92. The atomic number is going to be 92 because the atomic number always defines the element. So if I tell you carbon, right?
Yeah.
Carbon is always going to be 6, right? It's never going to be 7 because 7 is nitrogen. You understand?
Yes.
Okay, so your atomic number always defines the element. Okay. Okay, so the atomic mass.
246.
That's correct, 246. The mass number.
246.
246.
246. The number of protons.
92.
Number of neutrons.
154.
154.
Number of electrons. Oops.
92.
So, Dr. Henry?
Yep.
So basically, when we have, like, so we have 246 and then uranium. So, you know how, like, how on the table it shows that it's 238.03. So that gets disregarded then, right?
That's right.
Okay.
Because on the table is an average of all of the isotopes that exist in the entire world. And that's what you get on the table.
Okay.
Okay. So the uranium 246 is that specific isotope. So it's not the average.
Okay.
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 So do you guys, you got it? You get an understanding of it now?
Yes.
Mhm.
Yes.
Yes.
Okay. So now that I've got you, got you all shooken up, right? And who was it the one that was telling me about my table earlier? Who was that was speaking? Tiffany?
Yes.
Okay, Tiffany, are you ready for me to blow your mind some more?
Oh, yeah.
Okay, so let's get to the next part. ions, right? So you guys know what an isotope is? You know what an element is, and let's talk about what an ion is. So an ion is, it is a charged particle. Hold on 1 second.
Oh, we passed all this.
What's on the chart are all neutral, you said, right?
Hold on, just relax. I said elements on the table are all neutral.
Oh, okay.
Okay, so be careful. Don't put words in my mouth. Okay, so I want to keep this.
Oh, it doesn't say.
1 second to erase, and then I'll explain to you some goodness.
Oh, that's the last of it.
Okay.
Went too far. Did I?
There we go. Okay, so now this here is the nucleus. This is just showing you a big picture of the nucleus. Okay, so here in the nucleus, you have these electrons out here. Okay, so the nucleus is in the center, right? So your protons and your neutrons, they're pretty much like safe. Nobody's going to touch them, right? But you have your electrons out here in this space, and they're just circling around. So which is going to be easier to grab? Is it going to be harder to go inside of it, or is it going to be easier to go on the outside?
Outside.
From the outside.
You're on the outside.
Okay, so that's essentially it, right? So your electrons are going to be able to be plucked or added on. So we're going to be able to add electrons to that outside, or we're going to be able to pull electrons to the outside. Okay, so ions are just, they're charged particles. There's two types of ions. I can spell particles.
You said there's two types of ions?
Yep. Okay, I can't spell particles. Somebody spell it for me.
It's
C-A-R-T-I-C-L-E.
Thank you. Particles. Okay, so we have charged particles, right? So we have two types. We have what we call a positive charged particle, which we call a cation, because it's positive. You guys get that?
Yeah.
Nobody laughs at my joke. You're too serious. Relax. Breathe. Positive. Okay, and then we have a negative charge ion, and those are called anions. Okay, piece of cake. So you have positive and negative, right? Okay, so let me kind of give you a hint on how we define what's going to be positive and what's going to be negative. So, you guys, you're familiar with the noble gases?
Yeah.
These guys are the noble gases. Okay, now I want you to think about it and tell me your definition. I've got a lot of interesting definitions earlier today. Curious about what you guys are going to give me. Noble, what does that mean to you? If somebody's noble, or somebody's the nobility, who is nobility in our society?
Has nobility in our society?
Yeah, who has nobility in our society?
The Pope?
You said the Pope?
I guess, yeah.
Okay, the Pope.
That's about
Anyone
it.
else?
The Queen.
The Queen. Okay.
Yeah.
The president?
Okay, the president. You almost made me choke there. Okay, so, and then, let's see. When you were in high school, who was nobility in your high school?
Oh, you mean like who's popular?
Oh, so it was the popular kids, right? The cool kids. Okay, so what is the one thing about nobility? What is it about nobility? You know? So were you in high school, when you're in high school and you saw the cool kid there, you're like, God, I want to be just like Johnny. Johnny's so fucking cool. I want to be Johnny. Right? Right?
Are you talking about like a social class, like something that's important?
Yeah, right? And because they looked so cool and they were so stable, everything was so easy for them. Everybody loved them, right? So those are like the noble gases, right? They're so cool. They're so stable. Everybody wants to be like the noble gases. They'd give their left arm to be like their noble gases. So let's see. Let's say I was a Nigerian prince. And
That just needs my social security number to give me
I go
$1
to
million.
Eileen and I say, Eileen, I am from Nigeria. I have billions and billions of dollars. I have my own plane. I have everything. I love your eyes. I love your hair. Marry me. Be my wife. I won't even put a prenup. I love you so much. I know that, I'm the perfect person for you. What are you going to do?
Well, I have to get to know the person first.
Hell
but
no.
you're
Come on, millions of dollars. In 5 minutes she'd be on that plane. We'd be married in 10.
Yeah, but I want to be happy also. No, but I get what you're saying.
Sure, okay. I see how it is.
I get what you're saying. Realistically, most people would jump for it and be like, okay, cool, you got money, I'll be happy with that.
Yeah. What is that song? My Type? Is that, you guys know that song? Okay, so yeah, don't tell me. I know a large percentage of people be like, hell yeah, I'll be there 5 minutes, I'll definitely marry you. I would. I'd be like, that's stability, right? They pay my rent, they pay my house payment, everything be taken care of. I'm good. I don't have to work. I can just stay pretty, right? Go to the spas and everything, right? So
You fall into a Kanye West song, The Gold Digger.
Gold digger.
So the thing is that everybody wants to be like the noble gases. So they're going to do whatever they can to be that way, right? To get that way. They'll pair up with people. They do what they need to do. And part of that is forming ions. Okay, so we have the noble gases here. So we have oxygen, which is at 8. So now I told you that it's charged particles. So that means something is going to be going on. What's going to be going on is that either you're going to be gaining electrons or you're going to be losing electrons to try to get like the noble gases. So how far is oxygen from being a noble gas? How far away? It's 2 away, right? So if it gains 2 electrons, 1, 2, it'll be just like neon, right? It also has the option of going the other way. It could go 1, 2, 3, 4. Let's see. Sorry. 1, 2, 3, 4, 5, 6. 6 the other way, right? Yeah. So if it loses 6 electrons, it'll be like helium. If it gains 2 electrons, it's going to be like neon. Now I'm going to tell you this. If you had a choice to go to a store that's only 2 blocks away, or if you had a choice to go to the same type of store 6 blocks away, which one would you go to?
Closest.
You would go to the closest, right? Why?
Because you don't want to walk extra.
Yeah, you don't want to walk extra. That's exactly like these guys. So they're naturally lazy like us. So they're not going to walk those extra blocks if they can just go to the one that's right 2 blocks away, right? So they're going to find the easiest way, the shortest way to go to, right? So it's going to be like neon because it's closer to neon. So in that case, it's going to want to gain 2 electrons. Okay, so if it gains 2 electrons, how does that change the overall charge? So we're adding 2 more electrons. What's going to happen?
It's going to be a positive charge.
Is it going to be a positive charge? Because we're gaining electrons.
No, it's going to be negative.
So why is it going to be negative?
Because we're gaining electrons. Electrons are negative.
That's right, because electrons has a negative charge associated with it. So then it's going to have a 2 negative charge. Because it gained 2 electrons, which are negatively charged. You get that?
So it's an anion.
Okay, so let's say we have phosphorus, P. So what is it gonna do?
For P, it's
I
gonna
need
be three elements, right? So it's gonna be
Three electrons. So,
Negative.
so it's gonna be negative, three negative, right? Because it's gonna gain 3 electrons to be like argon. So that's 1, that's 2, that's 3. Piece of cake?
Mhm.
Okay, so let's get here. What about carbon?
It could go either way.
It can go either way, right? So we could have 4 plus. So if it loses 4 electrons, it's 1, 2, 3, 4. It's just like helium. If it gains 4, then it's just like neon. 1, 2, 3, 4. So it could be either way. Think about carbon. Carbon's such a whore. We'll talk about that here in a minute. Okay? Okay, do you guys get that? No?
So if the gain electrons are anions or whatever.
That's right. So if it gains electrons, it's an anion. If it loses electrons, it's a cation. Okay, so let's look at magnesium. Mg. What's going to be the charge on that if it forms an ion?
Negative or positive 2.
2 plus.
Yeah.
Right? Because the nearest noble gas to it is neon. So it's going to go, it's going to lose 1, it's going to lose 2, right? All right, 1, 2. Then it's just like neon. Okay? What about aluminum? Al.
5.
It's right here.
Plus 3.
Oh no, it's gonna be
3.
3.
Plus 3.
So 3 plus. So you always put the number first, and then you tell me the charge. So we're telling you, I have a 3 plus charge. Okay?
Dr. Henry, I'm a little confused. So I thought, okay. So which way is it going?
It's going this way, right? It's easier. That's 1, 2, 3.
Oh, okay, so we count. I'm sorry, I'm a little confused.
Yep. So I always do like this: 1, 2, and then back here 3. If it went the other way, that would be 1. It would be 1, 2, 3, 4, 5. So 5 blocks or 3 blocks, which is easier?
So you always go with the shortest.
You always want to go the shortest distance. Yes.
Okay.
And then does it have to be neon? Could it be helium? Does it matter which gas it is?
Oh yeah, it does, because here, this here is aluminum, right? If you go back 1, 2, 3, if it's helium, then you have to go back another 4, 5, 6, 7, 8, 9, 10, 11. You want to go back 11 blocks?
Nope.
So I never known anybody. There's a store 2 blocks away that's the same store. They're gonna go 11 blocks to get the same thing. Never heard anybody do that. So
Unless they're trying to work out.
yeah, unless they're trying to work out. That's a whole different story. Okay, how are you guys feeling on this? Simple?
Good.
Can we do a
You want a
practice?
couple? You want a couple of more to kind of work out the kinks?
Yes.
Okay.
Are you able to make your like pencil or whatever that is thicker? Because I think that's why it's kind of hard for the people to see which way you're going, I guess.
Yeah, let me see if I can do that. Give me one sec. Format. Let's make my, make my line thicker.
Yes.
Let's also get a more color-friendly. And you made me forget all the ones I had written down. Is that thicker?
Yeah, a little bit.
So that's gonna change all the rest of the numbers, huh?
What do you mean?
Like the atomic mass and all that stuff.
Is it? Is the atomic mass dependent on electrons?
No, I mean, yeah. So it's gonna change the what is it? Electrons. Oh, then no, I don't know.
We'll find out here in a second. Don't worry. Okay. So first one. FR.
Oh, I found it. So it's going to be, is it going to be 2?
No.
1 plus.
Wait, where's FR at?
Number
Right
87.
here.
Oh, okay. Oh yeah, 1 plus.
So 1 plus. So we just put a plus. We get lazy, we don't put the 1. It's understood. Okay. AS.
Okay.
That one too?
3 negative.
Oh my God, our side.
3 negative, right?
3. Okay.
Negative?
3 negative. Okay. SI.
Could go either way and be 4 positive or 4 negative.
Okay. F.
Question.
1 negative.
Okay. CA.
Counts. 2 positive.
2 positive.
TE.
2 negative.
2 negative.
B.
3 negative.
3 positive.
No, 3 positive.
BE. BE.
Two
2 positive.
positive.
Okay. Piece of cake. Okay. So I'm going to tell you something now so you'll know. You can kind of keep it in mind. All of the ones here in group 1, they're always going to form a plus or a +1 ion. The ones in group 2, they're going to always form a 2+ ion.
Because they're the same number away from that row.
Exactly. These guys here, these are going to form, in most cases, a 3+ ion. This one is going to be 4+ or 4-. In most cases. There are going to be some exceptions when we get down to here, because you see the things that are saying post-transitional metals, they behave kind of funky. Okay, these guys here, these are always going to be 3-. These are going to be 2-, and this is going to be 1-. Piece of cake?
So like just so RA would be just 1, right? It would just be the plus. So like if I'm instead of no, it would be 2, right? 2+.
Yes, it would be 2+.
Okay. All right.
Okay. Piece of cake, simple. Okay. We will talk about these guys later because they're a hot mess. These are all your transitional metals. And these guys here, these are considered your post-transitional metals. Okay. Hot mess, hot mess. Aluminum is pretty consistent. It's always going to be +3. So, okay. Any questions so far before we move on? Okay, so let's test those skills a little bit, right? So if I have, can I erase? I can erase?
Yes.
So we have V, and then we have V3 plus 54. Okay, so V, how many protons do we have? I mean, what is the atomic number?
23.
Number, mass number.
It would be I'm sorry.
Or, yeah.
50,
No, 51.
51.
Atomic mass.
It would
50.942.
50.
Oh,
Okay. Number of electrons.
23.
Number of protons.
23.
Number of neutrons.
It would be
51 minus 23.
so it'd be 28.
28. Yep. Is this an ion, isotope, or an element?
Element.
Okay.
so this is what I just wish.
Okay. What about this guy?
It would be 54, right?
The atomic number?
No, 23.
I'm sorry.
23. That's correct. Atomic, mass number?
Oh, that's going to be 54, right?
That's correct.
Okay.
The atomic mass?
54.
The number of electrons?
28.
23. 23.
No, wait.
Oh,
3.
3 plus. So it's what?
6. 51.
26.
plus 3 electrons.
No, 20.
It is 20.
Because you're
Man, I was
going
hearing so many numbers. I heard 51. Okay, so it's always going to be the same. If it's neutral, it's going to be the same number of protons, but it has a charge. It's telling us it's a plus charge. So that means we have to take away 3 electrons. So that gives us 20. Okay, so then how many protons do we have?
Wait, it was
23.
3? And it would be 20.
The number of protons?
23.
23.
Because you can never change the number of protons. That always defines the element. It's always going to be the same. 23. Number of neutrons?
34? Or no?
51.
Wouldn't it be 54 minus the 20?
It's 54 minus the 23.
Because
31.
What is it?
31.
31.
Okay. Piece of cake?
yes.
I
Kind of.
heard one person say yes. That
Yeah.
scares me.
I think if you probably give me one more, I'd probably get the hang of it.
Okay, you guys want one more? Un más?
Oh, and then it would be an ion and an isotope, right?
That's right. It is an ion and an isotope. That is correct.
Okay, cool.
So Tiffany, does that help with that problem that you were talking about?
Yes.
Okay. Let's see. Okay, so let's do another one, just to kind of top it off. You want to start? Let's start with the isotopes. Let's chart backwards here.
Okay.
Okay. Atomic number.
34.
34.
Mass number.
81.
What was it?
81.
Because that's 81.
1.
Atomic mass.
81.
Number of electrons.
That would be
32.
18.
Did somebody say 18?
Oh,
Oh no, what am I looking at? Sorry. Wrong thing.
32.
3.
Nope, not 32.
Oh, 36.
Oh, 39. What? What am I?
That's right. 36 is the correct answer. Number of protons.
34.
Number of neutrons.
Mass number minus. 50. No.
47.
47.
That's right, 47. So what is it?
An ion and an isotope.
It is an ion and isotope. What type of ion is it, if I asked you that?
It is an anion.
It is an anion. Okay, so let's go ahead and do the element now.
I have a question.
Okay,
At the bottom where it says ion, iso, or element, what are we looking for to choose whether it's either one of those three? Because I mean, the only thing I wrote on my notes as far as the anions is negative charge ion, and then a plus charge ion is the ketone.
okay, so is it an ion?
Yeah. So, well, yeah, but I'm just looking at what I'm asking is what are we looking at as far as the atomic number, mass number?
You actually look, you can actually look at you can look at the symbol, right? The symbol tells us it's charged, right? Because the definition of an ion is charged. So is it charged? Does it have a positive or a negative charge?
It has both.
This one has both. It has a positive and a negative charge.
What is the -2? Is that for the other column or?
No, the -2 is for this one right here. That's
Okay.
telling us it's negatively charged, right? Overall, you were talking about the overall charge. Is it a negative charge or is it a positive charge?
Positive, right? Because it's 81.
Nope.
Is that what we're looking at? Yeah,
Nope.
because I'm confused. I got lost. I was like, what are we doing?
Okay.
I know I got
So
lost too, but I figured it out.
anytime that you have a superscript, right? Se2-, that tells me I have 2 extra electrons, right? So normally it's balanced, it's 0, right? As an element. Se by itself has a total 0 charge. This tells me I added 2 more electrons. So is the overall molecule positive or negatively charged?
Negatively charged?
That's right, it's negatively charged because it says 2-. If I had Fe 2+, what does that mean?
Positive.
It's positively charged. Overall is positively charged. It also means that we lost 2 electrons, right? So this tells me how many electrons I have, right? So ions are just changing in electrons. If it's a negative, that means I gained how many electrons there are in here. So since it says 2, I gained 2 electrons. So I should have 2 more electrons than what I would normally have. If it's, in this case, Fe2+, right, that means I lost 2 electrons. So normally it has 26 electrons. So now I only have 24 electrons.
Okay, I got a little lost for a second too, but I think I figured when it's a negative charge, you add it, and so it would be an addition, right? And then,
Yep.
and if it was a positive, so you would subtract whatever the positive charge is.
That is correct,
Okay.
right?
Yeah, I'm not.
Yeah, and if you look at this, right? So the atomic number tells me always, the atomic number always tells me what?
It tells you the protons. I mean the number of protons it has, right?
That's right, it tells me the number of protons. So it tells me the number of protons. So I already know what my proton number is going to be, 34, right? So I know that at neutral, when it's 0, it has 34 electrons. But since I have 2 extra electrons, this tells me I have 2 extra electrons since it's negative. So then I add 2 to 34. So that gives me my number of electrons. So now I have 36 electrons.
Okay.
Right? This number here tells me my atomic mass. It also tells me my mass number. So here, this tells me my mass number is what?
81.
81. So that lets me know that it weighs 81. Okay, so then I put that for my atomic mass. So then I can also use my mass number to determine my number of neutrons by subtracting the number of protons.
Okay. It makes so much sense now. Thank you.
Okay? And so ions are changes in the number of electrons. So if you normally have 34 and you got 2 more extra electrons, it's an ion. If you normally have 34 and you lose 2 electrons, it's still an ion because it's losing electrons, okay? So ions basically mean that you're either losing or gaining electrons, okay? Isotopes means that you have neutrons, you have a change in the number of neutrons, so your mass is going to be different, okay? And then an element is what we see on our table here, on our periodic table. I'm pointing to it like you can see it with my hand. Elements are just what we have here, and we know that they're always going to be neutral charged, right? Piece of cake?
Yes. Piece of cake.
Okay, so SE, element, isotope, or ion?
Oh, it's an element.
It's an element.
Mm-hmm.
Okay, So let's go through real quick.
Okay.
Atomic number.
34.
Mass number.
79.
9.
How much?
70.
I heard
79.
79.
79. Okay. Okay. Atomic mass.
78.971.
Excellent. Okay. Electrons.
34.
Protons.
34.
34.
Neutrons.
45.
Piece of cake.
Yes.
That's an L.
Eileen. Did she leave me?
Oh.
Eileen dumped me. I guess we're not getting married.
What did you say? Repeat that again?
I said, did she leave?
No, I'm right here. It's just I was arguing with my son.
Okay. I was like, I guess she dumped me. I guess we're not getting married.
No, I'm here. I'm here.
Okay. Okay. How are you doing? You got it? Does that help?
Yes. Yes, I understand it more.
Okay. Okay, so let's see, I'm trying to make sure that I don't cheat you guys. Oh, okay, so now you kind of got an idea of how this works and everything.